to help you fill out your note guide. Remember from last set of notes, the octet rule. Octet means 8, so atoms tend to gain, becoming a negative anion, lose, becoming a positive cation, or share electrons, which be what we're going to talk about mostly today, to get that full outer energy of valence electrons. So, this is showing both nuclei, in other words, the centers, two positives, are going to do what like charges do and repel or push each other apart. However, the outside, the blue part here, the electron cloud part of an atom is negative. So that's going to be attracted to the other atom because negatives attract to positive. So if both atoms need to gain an electron, like they do in this picture, because there's only one electron here, so we're assuming this is hydrogen since there's only one positive, they would share them. So they get close enough. Can't get super close. They can't touch because the positives will push apart. They get close enough, this blues overlap, and they share those electrons, which means they are covalently bonded. This is showing, again, there's a perfect, you don't need to memorize this picture, but what it is showing, there's kind of a perfect distance where those electron shells, the blue part in the picture before, overlap, and that is considered to be a shared covalent bond. And up top, we see if the atoms are too far away, you're going to notice an attraction or a repulsion based on what they're made of. Each nucleus is going to try to attract the electrons from the other one, but the electron clouds are trying to push apart. Once you get a right enough distance, everything's kind of balanced, where the electrons are shared and that push apart, come together, forces balance each other out, and they end up actually keeping that position, and that's considered a covalent bond where they're sharing those electrons. What's most important, though, is that you realized covalent bonding is sharing electrons because both atoms involved need to gain electrons. And that's what this page is basically telling us. Covalent bonds form when two atoms share one or more pairs of electrons. Down here you see water. So the way this picture works, we look at the valence electrons of, this is oxygen, 1, 2, 3, 4, 5, 6, 7, 8, fills its octet. Hydrogen only needs 2 because it just has one energy level, 1, 2. This hydrogen has 1, 2. These electrons are shared between the hydrogen and the oxygen. These electrons are shared between this hydrogen and oxygen, but hey, sharing is covalent. We're going to have covalent bonds between two nonmetals because nonmetals need to gain electrons. And since if two nonmetals get close together, they both want to gain, so they're going to share to make them both full or happy. Press pause as you put these into your notes. All right, so we've already talked a little bit about ionic. Now today we're going to talk mostly about covalent, but don't forget your periodic table here. Elements can be classified as metals, this light blue column. Metalloids, which it's the white, we're not going to really worry about much. And then the nonmetals, the green. If we have a bond between metals, which lose electrons, and green, the nonmetals, which gain electrons, then those are going to be ionic because gaining and losing turns you into an ion. If we're looking at elements in this green portion, two nonmetals, well, they all need to gain, we said, so they're going to form covalent if they're joining together. Can't do this because you don't have the Pear Deck open. You can pause and answer this out loud or in your head. Metal and nonmetal, left side, right side, is ionic. Two metals, actually that's going to be a special kind called metallic. Covalent would be between two nonmetals, and that's what we've said here. And if you look at here, down in this picture, we have two chlorine atoms, here and here. They both have 7 valence electrons, which means they need to gain one. Well, they both want to gain one, so this chlorine atom's not going to give one away to make this one happy because then it needs 2. It's further away. So what happens is they get close enough together and they share that 8th electron. So it's considered both of them have 8 in their outer energy level, and that's why it's a covalent bond. They share. You can share more than one pair. If you look here, there's oxygen We're going to draw these Lewis dot structures eventually. Oxygen has 6 valence. Well, if 2 oxygens are near each other, they both need to gain 2, so they share 2 pairs. They will share those 2 electrons. Each of them will share 2. Nitrogen would need to share 3 pairs, and that's what this shows here. Go ahead and pause and put this in your notes. Properties of covalent bonds are pretty much the opposite of the ionic bond properties. The covalent bonds, if you're a covalently bonded compound, you're going to have low melting points, you're going to be soft and flexible, and you won't dissolve in water and cannot conduct electricity. So make sure you add that into your notes. Press pause before I move on. All right, so here is how we draw Lewis dot structures for these. Remember, Lewis dot structures are always going to be the valence electrons. So fluorine has 7 valence electrons. We draw the F for fluorine, our 7 dots around it. Well, this is still fluorine, so it has 7 dots. Well, they need 8. So what you do is either in step 3 or 4, we're going to prefer step 4, but step 3 is not technically wrong. You're going to draw it where they're close enough together that this is considered 1, 2, 3, 4, 5, 6, 7, 8. These 2 count for this one as well. 1, 2, 4, 6, 8. Once you get a little more comfortable with this, you're going to replace the shared pair with a bond, a line. This line counts as 2 electrons. So 2, 4, 6, this counts as 2 for this guy, 8. 2, 4, 6, this counts as 2 for this one as well, 8. Go ahead and draw a Lewis dot structure for this. Try your best. If you're wrong, it's okay. If you have no idea, just make sure you ask the next time you're in class to understand how to do it. And then you're good on your covalent bond notes.